those of you who haven't joined us before, basically the show and tells are, I pick a topic that comes to mind, and it may come to mind the day of the show and tell, it may come to mind a few days before, but I kind of pick a category of AT, and then I do my best just to kind of walk through it. I usually kind of have a bulleted list for myself, making sure I don't forget things to talk about, and I'll pull up websites, do live demos if I can, and just kind of go through the different pieces of the technology in that category. So the last time we met, Jenny, and you were there, we were talking about the voice control of different platforms. And so this is kind of in line with a comment I made during that show and tell, and that was the fact that, you know, voice control is great, but it's not foolproof. It's not, you know, just 100% accurate for you. So it's always good to have a second mode of operation. And I kind of referenced, you know, using wheelchair drive controls with the joysticks on them. So today's session actually just sort of is a spin-off of that comment. We're going to look at alternative and adapted keyboards and mice. So there's a lot to go through. And I'll just keep going until I think we all look at the time and say it's time, and then we kind of stop. And that'll be around 45 minutes. So if I have to make up more next time, then we will. But yeah, so I'm going to kind of go through them, talk about the kind of categories, features, use cases. Just consider it a big old survey of alternative keyboards. And I'm going to share my screen. I made a fancy PowerPoint for today. You are going to be very impressed. See? So I put a picture of each of the keyboards on each of the slides so that I can talk about them. Yes, this took much time and effort, so I want you all to just appreciate that. Okay, so adapted keyboards, adapted mice, you know, the obvious target here, thanks for the thumbs up and the party emojis. The obvious target here are individuals with physical disabilities. So upper extremity weakness, upper extremity spasticity, tremor, range of motion, you name it, any number of conditions can contribute to those difficulties. Repetitive stress injuries is a big one as well. So I'm kind of going to run through these, and I've broken these into categories, and I'll just introduce the categories as I get to them on the slides. But obviously the first one here is ergonomic keyboards. And I want to talk a little bit about the ergonomics of your keyboard, because there's a good chance that you have the keyboard that came with your computer, and it looks something like mine. Straight across, 128 keys, nothing fancy here. And I want to talk a little bit about what that means for your body. Okay, so the keyboard actually is a relic of, you know, earlier typing devices like typewriters. So typewriters were straight across, keyboards are straight across. It was kind of just a natural continuum. Well, it turns out that's not necessarily the best position for our bodies day in and day out. So when we're talking ergonomics, we're talking, you know, the marathon, not the sprint, right? It's what happens to your body over the course of time and extended use of the keyboard. And it turns out a straight across flat keyboard has a couple things going against it in terms of your physiology. It forces your arms into a couple different positions that are fine, but not great for extended, protracted use. So if you were to do a little exercise at home and you were to shake your wrists out and you put your hands right in front of you, your hands are going to come out in this angle. So they're not going to be flat, and they're not going to be turned like this. They're going to be tented somewhat, and there's going to be a straight angle here with your wrist and hand and forearm. And that's what we kind of refer to as a neutral posture. Your shoulders have neutral postures at rest. Your elbows will have a neutral posture. There's plenty of neutral postures out there. And basically that just means you're not spending a lot of energy, muscle energy, to maintain that particular posture. So if you were to put your hands back in that position and you were to make them flat, you're using muscles to flatten out, pronating those hands, right? And if you were to spread them sideways, deviate them out, then you're using muscle to actually send those wrists outward. Okay. Turns out that pronation and deviation are two things we have to do on our keyboard to get onto the keys properly for typing. We don't know it, we don't think about it, but yes, indeed, that's what's happening. It's not a significant amount of force until you develop an injury that is exacerbated by any type of those wrist movements. Carpal tunnel is one, as an example. Epicondylitis is one from the elbow, tennis elbow. And in those cases, those movements, those micro movements of the wrist end up actually taking a toll on the body, right? So it's the bad postures that lead to those kind of injuries, and it's those kind of injuries that exacerbate the bad postures, right? Your reaction to the bad postures. So it's kind of a negative cycle there. So long backstory there, but basically that brings us to a whole class of keyboards right now. And you can see the big dogs are in the race here. So you've got Logitech and Microsoft making ergonomic keyboards. And I want to point out just a couple of the features on this Logitech. I think this is the K860 ergonomic keyboard from Logitech. Really like this keyboard. Let's go over a few of the features. Obviously, it's split. So instead of having all the keys contiguous, they're split and they're angled. And what that angle and split does is takes the deviation out of your wrists. A very simple move to adjust to. It probably takes, you know, a week or two to kind of get comfortable typing on a split keyboard. Some people faster, some people longer, but immediately you lose the deviation in your wrists, and so there's less muscle tension there. The second thing, and from this angle, and I apologize for this, it's tough to see, but the keyboard is waved. So where that split is humped on the keyboard. And so that gives you a natural inclination for the keys on both sides. So that's putting your hands more into a neutral posture, and there's less pronation there. So it's reducing the need for pronation in the wrist. Those two postures alone are going to go a long way towards kind of relieving the stress on your wrist during typing. The other feature I want to talk about is the wrist rest there. And this particular keyboard has a really soft one. You know, when we're typing on a keyboard, what we're typically finding is you're stabilizing your wrist on a hard surface, in this case, my desk. And what I mean by stabilizing your wrist, you're usually putting pressure in this area. Well, when I mentioned carpal tunnel earlier, there's a little tunnel here called the carpal tunnel where the nerves that innervate the hand come through. And when you have kind of pressure in those areas, you're putting pressure on that tunnel. And that can put pressure on the nerves, create inflammation, scarring, and that's where you start getting conditions like carpal tunnel. So it behooves us to actually figure out a way to support our wrists without that kind of hard surface. And that's where those keyboard wrist rests come from. So super handy. The last feature I want to talk about on this particular device, and you can't see it, is the feet. And so I'm going to use my keyboard here. Typically on the bottom of your keyboard, you're going to have these two little feet right here, and they allow you to angle the keyboard, in this case up, or have it flat. For a lot of people with repetitive stress injuries, you know, angling up makes your wrists go into a different position now you're having to pull them back, and that's more muscle use on your wrist. So what we kind of look for sometimes for those individuals is a negative tilt on the keyboard. So your wrists are going down. And in those cases, there's on most ergonomic keyboard, there's feet not only on the top, but on the bottom. And that allow you to set separate degrees of a negative slope or a negative tilt and allow you to get that kind of wrist down neutral posture there. So lots of features in these keyboards. Learning to use them takes a little bit of practice and reading. I guess the last point before I move on and show you some different ergonomic keyboards is really the notion is it's not just the keyboard, it's the keyboard in relation to your body. So where that keyboard is positioned is super critical. Is it forcing your shoulders up because it's too high? Is it forcing your wrist back because it's angled up towards you? Is it too far away? Are you reaching to get to the keyboard? So there's just a lot that goes into placement. That said, having an ergonomic keyboard for most people versus a regular keyboard is probably a good idea, especially if you're on it a lot. But again, it's a systems approach. You really need to be looking at the big picture. So I'll get off my soapbox on that one. I'm going to go ahead and present, and hopefully you can see the big keys here, keyboards. All right, so this is Microsoft's version. I'm not going to repeat everything I just said, but you get the idea there. It's what we call sloped or tented in the middle, split, angled. It's got the nice wrist rest. It's got the footings on the bottom for the negative tilt. So again, the big players are in this space. The big players make quality keyboards. The actuators, I guess the other thing I would add on this slide is not all keyboard keys are the same. Right. So there's differences in the amount of actuation force or the force required to activate a key. And there's difference in the types of key mechanics. There's scissor keyboards, there's mechanical keyboards, there's electric keyboards. And the key feel is, one, deeply personal, and two, can really impact the amount of actuation force, can really impact a person physically if they have weakness in their upper extremities. And for some people with repetitive stress injuries, keyboards that are heavily clacky and take a lot of actuation force, that can be a fatiguing aspect as well. So it's not just the layout, it's kind of key mechanisms as well. All right, for some folks, we need to have a little bit more significant control over the amount of split and the position of the sides of the keyboard. And this is the Freestyle 2 from Kinesis. And this particular keyboard is designed, obviously, to be able to have the halves in any position you want. And actually, some people actually have these mounted on their chair, so their arms come straight out and there's no inward movement to get to the keyboard. And that helps them keep their elbows close to the body, shoulders in a fairly relaxed neutral position. Usually a keyboard like this is for someone that has some significant, the underpinnings of repetitive stress injury, and they're doing everything they can to keep neutral. The other thing that's interesting about the Freestyle is they have accessories for it that allow you to mount the two sides, the two halves vertically. So now you can actually type in this position. And while kind of keeping your wrists all the way up on their own, it takes muscle effort. But when you turn the whole arm in, see, when I do this, my elbows go in. And so there's still a lot of neutral posturing going on right here. So some people type really well in this kind of side-by-side typing posture. And something like the Freestyle 2 is going to allow them to do that. Okay, so let's talk contoured keyboards. So far, we've seen split, we've seen tented, we've talked about tented keyboards or sloped, we've talked about the negative tilt, we've talked about the keyboard actuation force, we've talked a lot of features. Now we're going to talk finger travel, okay? So even if your hands are in multiple, in a neutral posture, your fingers still have to travel to get around the keyboard. Right. And that's where something like the Advantage 2 from Kinesis comes into play. The contouring, the scooped layout of both sides of the keyboard actually significantly reduces finger travel. Okay. And you'll notice a little bit that when you start to get keyboards like this, you start to get, and most keyboards have them, but multiple functions per key. So you can hit the key and then there's a function key. So for example, in the upper row on the right there's the A key, but if you hold it down with the shift, it's going to give you the asterisk. So these contouring keys take advantage of that concept. So you can actually get more keys in a smaller space by pressing a modifier key on them, right? So again, the whole idea is reducing finger travel. And this is, again, really helpful for a person that does have some upper extremity weakness and range of motion issues. So not having to have those fingers travel as far is kind of a nice thing. And for people with significant repetitive stress injuries, not having to do those finger aerobics, finger twister to get on the shift key and then across to the T key, having it all more compact is super useful. So again, you notice everything is kind of still on that split arrangement. Taking this a little further, this is the Multron. Same exact concept, but you'll notice that you have the number pad in the middle, so it's more of an expanded type keyboard. You have access to all the keys, and you'll see the modifier blank keys on each side of the smaller, next to the arrow keys, the delete key. There's that blank key. So the Maltrons are super, super popular for people that really do struggle with repetitive stress injuries. But again, it does take some getting used to use these keyboards. All right, now for something completely different. I don't see these in the field that often, but it's a unique take on keyboarding. So the notion again is to get your hands in very neutral, comfortable position while typing. So it's split, obviously. There's a left and a right here. There's a nice ergonomically formed kind of place to put your hands. But if you look really closely, you're going to see these color bands here. And I apologize for the resolution of the image, but for each of those color bands, there's a different letter, right? So the way the keyboard works, if you look on the left, there's a color circle, and those colors on the circle, the green, the orange, the blue, the black, the red, those correspond with the individual bands on the keyboard, right? So the way this works is if I wanted to type the M key, which is at the top, I would take my left hand and I'd push the actuator up into the green, and then I would push my right hand up into the green, and that would set up an M because it's green, up, M. And similarly, if I wanted to do a G key, I could do the actuator on the left hand towards the yellow and my right hand towards the, just a little bit towards the left there, and that would activate a G. So you can imagine this takes some serious practice, but at the end of the day, you're using more larger muscle groups instead of finer muscle groups to do your typing. So when you're typing with your hand, it's all about dexterity, right? So your fingers are doing fine motor movements, your wrist is micro adjusting, right? When you're typing with this OrbiTouch keyboard, you're using larger muscle groups, your shoulders and your arms, and you're just making different motions with them, right? Obviously, a lot of practice goes into something like this, but some of the theory behind it is pretty sound. You're taking away the fine muscle movements and replacing them with larger muscle movements that typically aren't as taxing on the body, unless, of course, you have shoulder or elbow issues. This may not be your best bet. But that's the OrbiTouch. Again, a much more specialized, unique type of offering. Okay. That's a good segue for a specialized, unique type of offering. This is kind of, so the OrbiTouch is a little bit of a transition here into a new category of keyboards. So primarily we've been talking about ergonomic keyboards now. We're going to switch over to one-handed keyboards. And there's a technique to one-handed keyboards called chording. And chording basically is, as you would think of it on a piano, it's when you're pressing multiple keys together to get a new note or a new result, right? So obviously, when you're going to one hand, you're going to have many fewer keys to work with. And so the notion of combining keys together to make more keys than you have otherwise is a very powerful one. So the keyboard we have up in front of us is called the BAT keyboard, and this is a right-handed keyboard version of the BAT. So you'll notice some of the familiar things. It's got a wrist rest, 4 keys to work with your fingers, and then 3 with your thumbs, and the combination of which you press the red, the black, or the blue key with one of those 4 keys or multiple of those 4 keys will produce different letters or keystrokes on the keyboard. So this takes a significant amount of practice and getting used to, but for the people that choose a keyboard like this, that practice pays off, and typing rate can be very, very, very high. So it can be 30, 40, 50 words a minute with a technique like this. And yes, you can use a left and right hand BAT keyboard together. The chording would just be different in that scenario. So that is the BAT keyboard. A simpler version for one-handed users is the one-hand QWERTY by Matias. And basically, it took a QWERTY keyboard, cut it in half. And the way it works is, this would be a left-handed version. If you press the space bar, all of the keys remap to the other side of the keyboard. So if I want to press Q, I can use my pinky and press Q. If I want to press P, I would press the space bar and then press the Q key, and the P would come up, right? So it's, again, just another example of kind of very simple chording. What's nice about the 1/2 QWERTY is that it's there is a level of familiarity there because you're working with a standard QWERTY layout on a keyboard, and there's a bit of visual familiarity to the keyboard. It kind of sort of looks like a regular keyboard, except someone chopped it in half. So there's some pluses there, but again, it takes some time to become proficient with something like this. But typing words of 40 words a minute, typing rates of 40 words a minute aren't unheard of with something like the 1/2 QWERTY. Maltron, again, they made the dual. They also make the single-handed keyboards, and they make them in left and right layouts. So this is the left-hand layout for the Maltron. Again, not too much different here than before. One thing I will say about the Maltrons is they're a classic example of a mechanically actuated keyboard, and a lot of people really like that actuation style, mechanical versus more electrical contact sensor, just because there's some tactile feedback to the actuation of the key. So if you've got some sensory issues in your fingers, or you're prone to kind of keyboarding mistakes, having that key travel, right? So there's activation force. I guess I should add key travel to the list. Having that key travel is really cool, because it gives you an idea that that key is being activated, right? There's just some biomechanical feedback there. So, gosh, you guys are learning all the technical terms today. So the next one-handed keyboard, literally it's on one hand there. This is called the tap keyboard. Again, very niche, very specific product. And the way the tap keyboard works is it's got motion detecting. It's basically worn, it's kind of a semi-glove across your fingers. And as you tap on the surface and with different keys, almost like chording again on a piano, you're going to be able to type out a variety of, you'll be able to type. So what's interesting with the tap is you're not limited to the desk in front of you. You can tap on your thigh. You can type in many more physical positions than you could with most other keyboards. Honestly, just because it's on your hand, right? You could probably type like this if you wanted to. So the tap is a pretty interesting device. I've never used it personally, but there you have it. I want to show you all the options that are out there today. Well, not all of them, but most of them. Thanks for the thumbs up. This is called the Typee, and it's kind of a different take on one-handed keyboards. What you'll notice here is, and this is an introduction to alternative layouts on keyboards. So for the most part so far, we've seen the QWERTY layout or we've seen a chording layout, nothing different. So this is more of a frequency layout based upon the position of your hand on that wrist rest. And it's kind of basically the idea is let's compact the keys, let's reduce finger travel to the different keys, and let's put the most frequently used keys within the closest distance of your fingers at neutral on the keyboard. So this kind of gets us into the mini keyboard realm. So the keyboard is smaller. I've never used this before, but you'll notice that there's definitely some function number lock and whatnot that you need to be able to do to get to some of the extra symbols on the keys. So that's the Typee. All right. So we've covered ergonomic keyboards, one-handed keyboards, and now we're going to go into programmable keyboards. And this is a keyboard from a company called X-Keys. And the thing that this keyboard does that's really interesting is that you can program each and every one of those keys to do almost anything you want. So there's corresponding software that goes on the computer, and it is basically enables macros, which are basically you can record a series of actions using keyboard shortcuts, mouse movements, and even programming. If you're so inclined. And so what it allows you to do is basically synthesize a series of steps, like opening an email program, checking the for new mail button, putting the mouse into the first item in the inbox list, and then launching a text-to-speech program to read that message, right? So all those things can be done with one keyboard hit. So typically, programmable keyboards are accessory keyboards. They go alongside a traditional keyboard, and they allow you to assign quick actions to tasks you do repetitively. And so they come in tons of formats. They come in strips or bars that go above your keyboard. They come in boxes. They come in like 10 key kind of packages. It's crazy the amount and flexibility. Again, probably for the more savvy, sophisticated user, programmers, accountants that are doing a ton of repetitive work. I would imagine, video professionals would benefit from this because there's a ton of, repetitive mouse options that they do when they're doing video editing and cutting and whatnot. So those are programmable keyboards. The good news, you can actually buy macro software and just program keys on your regular keyboard, but that's for another day. Okay, next category is key guards. And key guards don't get the love these days that they used to, and they really, really should. They have a ton of benefits for specific individuals. And, the classic use case that comes to my mind is an individual with cerebral palsy that has spasticity and difficulty isolating fine motor movements. So they may have tightness in the wrist and they can get a finger out, but targeting a key is difficult. So a couple of things need to happen. One, they need to stabilize their body to kind of keep that spasticity at bay. And two, they need to turn around and target an individual key. What typically happens, what can happen frequently, is the targeting is not completely accurate. And so they're hitting two keys at once. So they're going for the P key, but they actually hit the O and the P key at the same time. So that's an error, hitting two keys at once. Another thing that can happen is another part of the hand can actually activate a key on the way to stabilizing to get on a key. So that's not useful. Another thing that can happen if you have spasticity or tremor is when you get on a key and there's nothing to support your hand on, you can bounce on that key and it gets activated multiple times. So there's lots of room for error here. And it's not just for an individual with spasticity. It's also for individuals that may use a pointing device. So I'm just going to pretend here this is a pointing device where they have a grip and then they can use the pointing device to type on the keys. Targeting like that it can be a challenge. Some people use head sticks or mouth sticks as well. What a key guard does, and I'm gonna channel my age here for a second, and people who watch this that are younger than I may laugh, but back in the day we had rotary telephones, and each of the numbers on the dial had a cover over it, and there's a hole over each of the numbers. So you can stick your finger in and turn the dial, rotate the dial to call someone. That's a key guard. Right, so same notion here. You can see this plastic overlay, and so basically what it does is it provides a tactile, visual, and protective target for each of the keys. So now it's almost impossible to hit two keys at once, right? So targeting becomes much easier. The second thing you can do is rest your hand on the keyboard now. So now you have a place in proximity to the key to rest your hand or arm, and without activating keys. And obviously with a mouse stick or a pointer, it's a super useful device as well. What's nice about the key guards, there's a company called KeyGuard AT. I think it's keyguardat.com. They actually make key guards for common and popular keyboards. So they do it for the Apple Magic keyboards, they do it for the Logitech, they do it for a Microsoft keyboard. And so there's a bunch of different key guards out there that they can make. And I wonder even if they can make custom one-off keyboards as well. I think that may be a feature that they can provide. And these things aren't that expensive. So a key guard like this, I think is $40. It's not an expensive outlay in terms of money. Okay, another example of a key guard. This is again from Maltron. It's their expanded keyboard. What's nice about this is it spreads the targets out for a person. So there's a little bit wider space between the different keys. Obviously, this is going to require more range of motion for an individual. But for the right person, a key guard like this is super helpful. Again, specialty product, not widely distributed. Okay, the last one I'm going to do for keyboards, I think, is another Multron, and this one's designed for head and mouse stick users. And again, if you'll notice the keyboard layout, it's atypical, right? It's not your standard QWERTY. It's frequency of use, middle outwards. So that's what you get there. And this is designed to be sat vertically and accessed at an angle with a mouse stick or a head stick. All right, last little bit here on keyboards, and then we're going to switch over. Actually, let's see what our time is. Yeah, we have a little time here. So this is a Dvorak style keyboard. And Dvorak is actually a much more efficient style layout for a keyboard. QWERTY came from typewriters, and fun fact, the reason the QWERTY layout was developed, one of the big reasons is typewriter keys used to jam as you typed, right? When they all came up at the same time when you're typing quickly. So QWERTY was actually designed to inefficiently lay out those strikes on an old school keyboard so that they wouldn't jam when you're typing fast, right? So no thought was really put into what's the most efficient layout for a person who's going to be typing on a keyboard and doesn't have to worry about those typewriter strikes. Well, that happened a little later with the Dvorak layout, and there's several other layouts out there. You know, and proponents of Dvorak who use it, they love it, right? But again, there is, you know, a certain friction to learning a whole new layout. So most of us don't, and most of us get by just fine with high, and you know, we can type at fairly fast speeds, but the efficiency of Dvorak is well established. Okay. Whew, there you go, keyboards. Let's talk mice. All right, so this is your standard 10-pin trackball. So when we're talking about alternative or adapted mice, we're talking about a few different categories. You've got your trackballs, you've got your ergonomic mice, you've got your joysticks, you've got your head trackers, you've got your eye gaze, and a number of, you've got your mini type mice that require very little movement. So let's go through some of these. This is a standard Kensington trackball. What I love about it is the ball actuates really well, and those buttons can be programmed to do single click, double click, triple click, click and drag. So one of the big issues when you're talking about alternative mice is not only just manipulating the mouse, right? It's also performing those click actions. And one of the bigger issues in repetitive stress injuries when you're talking pointing devices like mice is that click. The motor movements required to do a click, right? You're typically curling your fingers back and then you're pushing your fingers down, and that's activating this entire area that can exacerbate discomfort and pain. So love that feature in the Kensington. Another example of a trackball. Again, you'll notice a nice wrist rest there, and it's kind of curved up, so you can put your hand in a fairly neutral posture on the ball, use maybe the tip of the finger. So very, very helpful design. And what I love about trackballs is that there are a million out there. So again, there's some personal preference involved. So these are placed on top, but they've got trackballs that are placed on the side to put your wrist again in a neutral posture, less pronation. Speaking about less pronation, this is actually a standard mouse, and this is made by, I believe this is Logitech's device. Yep, it is. And again, designed to put your hand in this position and have the buttons in a place that you can activate with your thumb, which is a larger muscle group with not a lot of force required. So super useful little device. This is another one called the Evoluent mouse. Same idea. Your wrist is in that neutral posture. Gives you 3 buttons on the side there, plus some extra buttons and a scroll wheel. And actually, there's buttons on the thumb side as well that I can't show you. But again, the whole idea is to get your wrist in a neutral posture. This is the 3M, and it may look like a joystick, but it is not. That is just a handle, okay? And the base of that, there's just like the laser mouse on the bottom of a regular mouse, and you're moving the mouse again with larger muscle movements versus these small articulations of the wrist, right? So that's kind of its design ethos. The left and right click buttons are on that little toggle in the middle there, left to right with your thumb to activate those. So lots of options for people that have difficulty with a traditional mouse. This is an odd one, and I don't mean that in a bad way. I guess mean that as more as it's more of kind of a one-off specialty device. I would put it in the same category as the OrbiTouch. So basically, the idea is you can use this like a pen. Okay, and there's a scroll wheel on it. The base is just like the base of a regular mouse, and you kind of move around the mouse like you would a pen. And that's taking the finger down into a more natural, instead of spreading the hand out, you've got a more natural grasp on that pen. Never used it personally, but I think for the right person, it might be a useful device. Okay, so covered ergonomic kind of devices. Now we're going to talk a little bit more about specialty devices. And again, we talked about trackballs and joysticks as categories. And this is an example from the same company. The device is called the Enabler, and they've got a trackball version and a joystick version. We'll talk about a few of the features of these that are really, really neat. One obvious one is those buttons, the actuation buttons there, they're all key guarded, right? So you can rest your wrist on there and not accidentally hit one of the buttons. They're programmed for single click, double click, click and drag, and they can be programmed otherwise, which is a really great feature, right? The recessed trackball is kind of a neat thing, because what happens is you can, instead of having your hand on a, let's say this is a regular trackball, and you've got your hand here, you've got your wrist coming up on top to use the ball. I'm sorry, that's probably not a very good demonstration, but when it's recessed into the device, your whole wrist can lay flat and just the very side touches the top of the ball. And so that can be very useful for someone that does have some level of spasticity, and it's hard for them to get up on top of a ball that's sitting on top of a device. So super, super useful. Again, the tracking speed, all of the kind of features of standard mouse can be controlled with the settings and easily access settings on these devices. So you don't actually have to go into the computer, into the mouse control panel and change things. You can and I love this feature, you can actually change those characteristics on the hardware itself just with gross motor button pushes. So it's again, super, super nice device for people with more significant physical disabilities. And the difference here is, again, trackpad versus joystick. One of the interesting things about both of these will do it, but joystick is especially useful. When I talked about the wheelchair drive controls, I introduced the notion of proportional versus digital or directional kind of control. So proportional is, no matter which way you move that joystick or trackball or mouse, it's going to go directly in that position, right? So you can move it as any direction you want at any speed you want. A directional or digital kind of control is you're locked into up, down, left, right. And this is great for individuals that have spasticity, because if it's proportional and they're kind of having this kind of muscle reaction, that mouse is going to go everywhere. But if it's directional and they're going like this, but the general direction is up, that mouse is going to track straight up the entire time, right? So they can track themselves left and right, up and down to get to the target they want, and then release. So super, super useful feature. And that's that black button top in the middle of the device. And again, another example of trackball and joystick devices. These are the Optimums, I think. Optimus, and they're just a slightly little less efficient. Featured in terms of the buttons that you have access to. One thing I do want to point out on the side of these, and this is available on the Enabler as well, is controlling the joystick or the trackball is one thing. Clicking can be another thing altogether. And so what these devices offer, and you see these little jack points on the sides at the bottom, are switch jacks. So you can use a capability switch or an ability switch that's mounted somewhere on the person's body, their elbow, their knee, to be able to activate the switch clicks, which is really cool. So lots of features in these specialty devices. Another example of a joystick, this is the point it, and you can see the different mouse capabilities that are programmed in those buttons. Those are more touch sensitive buttons, capacitive, than they are mechanical. For some people that's more useful. And you can see there's 2 switch jacks on this particular device, which is cool. This is a chin joystick. So far we've been talking about managing the pointing device with your hand in some way. Well, this is a system designed specifically for you to use your chin to control the device. So lots of options out there. Again, we have another joystick here with button key guards. And so really not too much different, just a different form factor from the enablers and the Optimax I showed you earlier. The one on the left is kind of interesting. It is nice because it just leaves you with directionality, left, right, up, down. And for some people, that's the easiest way for them to get around with mousing. So, okay. So now we're going to move off of joysticks and ergonomic mice, and we're going to go to touchpads. There's a category of people out there that do really well with touchpads. One of the reasons is that the force from the travel distance is very small. You can do it with just a single finger for most of them. The gestures that these things offer are super useful. So you can actually use specific gestures depending on the device. And what I mean by a gesture is, let's say I swipe my finger in a circle. That could be assigned to go back in a web browser, right? I swipe down like this, and that could be scroll down if I'm on the very right side of the pad there. So this is the GlidePoint touchpad. It's a mainstream product. So there's some useful features on this for the right person. So a little bit more advanced version of this is the Orbitrack, and it is completely touch centric. And you'll see the double click, you'll see the left and right clicks, you'll see that the click and drag, I guess, is another feature that I didn't mention. Many of the previous ones, devices had this as well. Is clicking and dragging can be a difficult, a little bit of yoga to do, holding down the button and then moving the mouse somewhere, especially if you have tremor or especially if you have spasticity. So nice features. What this does, it takes most of the actuation force out of the puzzle, right? So, and gives you a nice big place to rest that palm of your hand. Okay, so you're getting there's some recurrent themes here, right? So stabilization and actuation force and protecting against spasticity and tremor, preventing those errors associated with those. So most of these products are pretty darn well thought out and worth investigating. Okay, so the next category would be very limited movement type devices. And this is the Genius, I think the Ring mouse or GlidePoint mouse. I may have that wrong, and I apologize if I do. But the notion is it's just right on your first finger and then your thumb's activating everything, right? So you're not having to do much movement at all. And again, you can have your hand in your lap, have your hand positioned multiple areas. It's kind of a neat idea. Another take on this similar idea is this this mouse, and this is like a little pad that you put your thumb on the pad, and you can control the mouse that way. And then those buttons, A, B, C, D, are programmable buttons. Again, they're more capacitive for tapping. So this is, again, for someone that may have some fairly significant weakness and range of motion issues in their upper extremity. So, all right. Some more specialty here. Now we're talking about a person that probably doesn't have upper extremity function, but still wants to do some mousing on the computer. This is called the Integra Plus, and basically it is a mouse you activate with your mouth. And so it's got full directionality. It's got a kind of a puff characteristic for clicking, and it's plug and play because you see the USB adapter right there. So that's the Integra Plus. Another device in this category is a Joust 3, and you can see this one just mounted on an arm, and the person is going to use that joystick with a kind of, in this case, bite down on that stick at the top, and they'll be able to use their head and the bite to control the cursor on the screen. And again, there's click capability with puffing into the device. So useful little thing. All right, I think we're getting close here, looking at the time. So I will finish up since we've got I know we're pretty close to time. So this is the foot mouse. designed for individuals who really the upper extremity is not an option for them. Maybe their repetitive stretch injuries are so difficult. I mean, just so significant that no matter what we try with the upper extremities, we got to try something different. So, the foot actuators on the right there and the buttons are on the left. It's pretty self-explanatory. One thing you do need to know about a foot mouse is you have to have postural stability to use it. So it does take a little bit of work in terms of positioning correctly. Otherwise, you can build up some fatigue, kind of stabilizing your body so you can use your feet. So really, there's a lot that needs to be thought about in terms of body positioning and stabilization to use a device like that. And this is the Boomer. It's another foot style mouse. Actuators in the middle, and the left and right clicks are on the obviously left and right respectively. So specialty mice. These are basically what we call head mice or head tracking mice. And this one is a Head Mouse Pro, and it uses an optical tracker. And so ideally, you would have a dot or reflective dot either on your forehead, on a pair of glasses you're wearing, on a ball cap, something that device can lock onto. And then when you're controlling your head movement, it's going to move the mouse on the screen. Again, we're going away from kind of that body physical legs, hands, feet, fingers, and we're going to kind of the head movement. And first, when we're looking at relative control, when you have loss of function, for a lot of people, there's more relative control in the head versus some of the extremities. Okay, not for everyone, but when you're looking at mousing on a computer, you're going to look at where's the best level of function for that person. Again, there's some body stabilization that goes into this as well. So that's something to keep in mind. And I'm just going to show you a couple other versions of this. This is the Tracker Pro. Again, same idea. It mounts on your computer. Infrared kind of tracking system, works with a dot. This is a Natural Point Smart Nav. Same idea. Nothing new here. I kind of put them in order of popularity. The Head Mouse is very popular, followed closely by the Tracker Pro. The Smart Nav by Natural Point is a little less, or Natural Point by Smart Nav, I'm not sure which way that goes, a little less popular, but they all do fundamentally the same thing. Okay, and you might be wondering, why is there a Logitech webcam there? Well, you can actually download free software for a Windows computer called Camera Mouse, and it actually uses the camera, the webcam on your computer to lock onto a facial feature, and typically it's the tip of your nose. And so you kind of train it to lock onto your nose, and then you can move the mouse that way as well. And you use that kind of software in conjunction with another type of software called Dwell or Dwell Click software, which basically allows an on-screen little toolbar that you can activate to set your mouse into single click mode or double click mode. And the way it works is when your mouse gets on a target, if you dwell there for a set amount of time, say half a second or a second, it'll then send an automatic click or double click, depending on what you've chosen from the toolbar. Right, so you can actually have complete hands-free mousing use with, free software, because there is a free version of that Click and Dwell software out there as well. Okay, and this is eye gaze. Typically with eye gaze, it's going to be built into a system, and typically that system is a communication device. So Dynavox or Prankuromic devices and many others, they're going to have this eye gaze technology built in. Again, designed for people with pretty significant physical disabilities where even head control and movement is not sufficient, but they do have relatively good control of tracking with their eye muscles, right? So typically it's bought as a package with a communication device or a dedicated system, but it can also be purchased as a standalone bar. And this is the Tobii 5 series, and it basically is a USB device. You plug it in, you adhese it to the bottom of your monitor, and Windows 10 has a built-in driver for these Tobii devices, and so you can immediately start with eye gaze. As you can imagine, there's a lot of calibration involved and a lot of physical stability and stabilizing that needs to happen as well. But this technology is getting better and better. Okay. Whew, just inside 50 minutes, I think, not too bad. That is your crash course in adaptive mice and keyboards. And I guess the important considerations is these things aren't always cheap. They really do require you to work closely with an occupational therapist or physical therapist who's really has a good understanding of human factors and positioning, because it's easy to inadvertently set up a keyboard in the wrong place that's going to create kind of an issue down the road for a person physically, even best intentions, even with trained people. So it's important to have that kind of look. The other piece that's important is to know that the keyboard is one part of the puzzle, but the features that the keyboards offer are another. So making sure that, you know, or the mouse, making sure the tracking speed on the mouse is set correctly, making sure the pointer size is set correctly, making sure that you have larger targets on the screen will make things easier for people. So it's kind of a system of access if you kind of think of it that way. So, all right. I think I've shared enough with you guys. I will come up with the next topic for next week sometime in the next few days, and I'll deliver then. So, but Jenny, before I pop off, and I want to respect everyone's time, did you have any questions that you wanted to ask?
No, really great information. Thank you so much.
You're very welcome. All right. Well, I will see folks next week maybe. And until then, have a great weekend and we'll talk later.
Thank you.
Bye everybody.